It's great that we can store things in the cloud, for example, but at some point we're probably going to want compute resources in the cloud. Maybe we're hosting a website and we want the web server to be completely in our control, so we want to spin up a web server in the cloud. Maybe we're going to be hosting a SQL Server database in the cloud and we want complete control. So we want to spin up a Windows Server 2016 system, for example, and we want to install SQL Server on top of that and control everything. These are some scenarios of the many that we can accomplish thanks to compute services inside of Amazon Web Services. When you're looking at your services in Amazon Web Services, notice that there is a category called compute, and the very first entry is the foundational compute service that we're so accustomed to with AWS. It's Elastic Cloud Compute, or EC2. Notice when you go there, you start at your EC2 dashboard, and I can see that I have a running instance going right now. Its name is Management Linux, and I can get details on it right down here under the description area. It's running on an instance type called T2 Micro. What this means is it's got very little hardware resources dedicated to it. So a little bit of RAM, a little bit of CPU power. This is great for just a little management Linux box, which is exactly what I wanted it for. But you can go in and you can choose the launch instance and you can create something entirely more sophisticated. So we could go down and launch like a Windows Server 2016 base image and then install SQL Server on top of it. Or you could go over here to the AWS Marketplace and you could find someone that's already created that EC2 instance for you. The SQL Server installed already, and you could take advantage of that EC2 instance. But what's really exciting lately, if we go back to the main services page, is Lambda. Why Lambda is so exciting is because you don't even need to run servers. You don't need to spin up those EC2 instances. Instead, what you can do is have some event trigger. Maybe like we upload something into an S3 storage bucket, and based on the fact that something just uploaded, that's called a trigger, we can send that trigger up to Lambda and have Lambda do some type of compute function. Maybe we want to create a thumbnail image for the JPEG that we just uploaded into the S3 bucket. No problem. We write what's called a function inside of Lambda that will be triggered with the JPEG upload, and it does the compute for us, and we don't need to worry about any of the EC2 instance spin-up. Serverless cloud computing is the rage, and Amazon Web Services with Lambda and Microsoft with Azure, there's lots of different cloud vendors now that are starting to implement this. Another really cool compute resource that you need to be aware of as a cloud practitioner is called Elastic Beanstalk. What this is more automation for us. Your application developers, they want to take advantage of using the Amazon Web Service cloud to deploy their applications, but they don't want to be caught up in the gory details of building servers and networks and firewalls and load balancers and all that stuff. So they can come into Elastic Beanstalk and they can quickly select a platform, upload their application, and that's it. They are now fully implemented with cloud. This automates the creation of all the underlying components that this application developer would need inside of Amazon Web Services. So this is automated. They just choose what platform they want, then they upload their app, and that's it. It's really amazing. Now, something I want to discuss with you that is done automatically in this process or manually that we would have to do is when you're going into, let's say, EC2, and let's say you spin up a web server, one of the things that can happen is you can quickly outgrow that web server. So maybe you want to spin up 3 web servers, all containing your website. Now you need a way to load balance between them. And as you can see right here inside of our EC2 options, if you scroll down, there is a load balancer option. So we have the ability to also spin up a load balancer inside of Amazon Web Services, and this will take requests of that web server that you're getting, and it can distribute them across your different web servers. Notice that we can do a network load balancer or a more sophisticated type of application load balancer, but the end result is the same. A lot of different client requests can be distributed across your different compute resources automatically by the load balancer. So that certainly was a lot of information. Let's review it real quick. We have lots of options when it comes to compute resources inside of Amazon Web Services. We know, for instance, we have EC2, which allows us to spin up virtual machines inside of Amazon Web Services with the software that we need. But if we want to go serverless, we have Lambda. Lambda allows us to not even spin up any servers and still get compute functions done. Our developers may want to take advantage of Elastic Beanstalk, and that'll allow them to have all of this EC2 and load balancer and network stuff created for them so that they can just upload their application. And finally, we also took a look at elastic load balancing inside of Amazon Web Services. We know we can do it kind of classically, what is called network load balancing, or we can do a more sophisticated variation and load balance based on different applications that we're running. I hope you found this nugget informative, and I'd like to thank you for viewing.